we've done today is, if you know anything about us, we are known to do things a little upside down. That's kind of way we operate. We tend to challenge everything that is out there. So we will not be boring you with too many slides today. We'll get right down to it. We'll open up the code and talk to you about how the ad platform works, and then based on questions, based on how your understanding of what we're here to show you. We have other content to show you based on the questions. So there are a few slides if you want. But what we'll do up front is, of course, we'll all introduce ourselves, and then I want Kevin and Colin to talk to you about the story of how the ad company was born. Because it's important, very important for you guys to understand that this is not like an overnight idea. This is something that Kevin and Colin have been almost thinking about for a decade and trying out different ways. And just 2 years ago, the technology was right, the time was right for us to embark on this journey. So it's important for you to hear that backstory. And then we'll get into some code, see how the platform works. We're here to show you something really cool, how you can enable chat on any application, on a Flutter application with just 2 lines of code. So you'll see the power of the ad platform in action. And then, like I said, we'll walk you through what the ad sign is and how you can get an ad sign, how can you be part of the ad platform, all of that good stuff. So we'll keep it very casual. This is a small group. Feel free to interrupt us at any time. So that's basically what we'll try to do for the next hour or so. Does it sound good, Sid?
Yeah, all good.
All right. So, Colin, Kevin, over to you. Why don't you do a quick introduction? Tell us the story about how the ad company was formed.
Go for it, Colin. Sorry, my.
Uh-oh, we lost Colin.
Okay, well, how about I'll do it then. So, hey everyone, I'm Kevin, one of the founders of the company. Been doing startups for a long time, the idea for this company started about 7 years ago, and it's something I've been actually working on since about 2005. So it's 15, 16 years. I actually did an implementation back in 2008 and then shelved it. And then Colin and I did another trial implementation about 7 years ago. And didn't quite have the right idea and didn't quite have the technology wasn't quite ready. So fortunately, Flutter and Dart came along, and that was magical, as well as some capabilities in phones and so on. But the idea originated, we were actually at an incubator in Sunnyvale, California, and just got to talking over coffee and figured that this is something we were both really interested in. And as we were talking, we were trying to say, well, how do you solve the identity problem on the internet, whatever the hell that means? And that could either be a very long answer or a very short answer. And so the question we asked ourselves was, well, ignoring everything that's been done up to date, what if we ask the question, what is the simplest way to establish an identity on the internet? And the answer was a unique string. And that's where the idea for an at sign was born. So an at sign is a unique string in a directory service, and the directory service knows nothing other than the location of your server that you control, that has your data that's encrypted with keys that you control. And so everything else kind of builds from that. And we knew right away we wanted to do an internet protocol so that we could have information exchange between people and people and things and people and companies, all be done at a protocol level so that you have the kind of ultimate interoperability. And so we built a protocol for the secure exchange of information between 2 known parties. And there's a couple of key things there. So one is securely exchanging. So this is all about end-to-end encryption. So you're going to see how to build an end-to-end encrypted app in about 5 minutes today. Otherwise, if you think about if you were to go out and build an end-to-end encrypted app, not easy. It took a lot of work and a lot of thought and a lot of potential mistakes to make. And the other part is that the parties are on both sides of the exchange are known to each other cryptographically. And so, Colin, are you on?
Yeah, Colin's on.
Yeah, I'm here. I'm just trying to get up another screen so you can actually watch the demo, because we're used to Zoom, and on Google, you can't share half a screen. You have to share the whole screen, and you won't get my 94-inch screen on your screen. So,
okay,
give me a couple of seconds.
Alrighty. Well, so that's where it came from. About 7 years ago, we started cutting codes. We figured out, obviously we have to do this in blockchain, and so we did what 36 other companies are doing now, which is blockchain plus DNS, and very quickly realized that was a terrible idea, and so we tossed it out the bin, and then we ended up actually rewriting everything with our own protocol, which is all completely open source. I mean, everything we do is open source, and we literally run what's in our repo is how we run our production services. And we'll show you how those work here, hopefully shortly.
Yeah, so maybe, Kevin, what I can do is, while Colin is getting ready, I can walk through something really fun. So Kevin mentioned something about the @sign, right? So he mentioned about the unique string or your identifier for yourself on the internet. So this is basically, even though it is private, end-to-end encrypted, it is person-to-person, that sort of thing, you can have your own public space on the internet on the platform. So the @Wavy app is a way to do that. So this is available right now on the Play Store as well as on the App Store. So if you want to get started on the platform, get started on the @sign journey, this is a very simple way for you to do that. So just look at, it used to be called @persona. That's what you see on the top, but right now it's Wavy. So our vision for this is, I mean, as the notes say, it's a public space. And if somebody says, hey, I mean, give me your information, what is your LinkedIn? What is your Instagram? You don't have to give all of those, away separately, or you can have any information that you think is public on the Wavy page. And all you need to do is just give away that string to people to share information on the platform. So through the Wavy app, you set it up, and we have something called wavy.ng, which is where you basically go and look up people, right? So for example, if this is an @sign that somebody has picked, you can set up your public profile with whatever information you'd like. I mean, it is basically free-flowing, as you can see. It gives you a different way of organizing compared to a set template. So you can add HTML embeds, you can have a video in there, you can have images in there, any sort of content is available. So this is a personal, individual Wavy page. And you will also notice that businesses have actually set this up on the Wavy page. This is an example of, if a business were to get an @sign, in this case it is this particular @sign, and they've set it up to showcase, much like a website, they've set this up to showcase everything that the business is about. What do they produce? What is their store? Everything is possible, I mean, up to your imagination, essentially, on the Wavy page. The question you might have on your mind is, hey, how do I get an @sign? So if you go to our website, @sign.com, and click on Get an @sign, you can get a free @sign very quickly, within few minutes, and you could be on your way to getting started on the Wavy app or other apps that our developers are working on. But I mean, Wavy I bring it up because, I mean, that's your first step on this journey to create your public profile, if you will. And then, like I showed you, I mean, those are all several examples of what people have done with setting up your public space on the ad platform. Colin, you ready?
I am.
Awesome.
I had to hack another second screen up, so stole one for my wife.
All right, perfect. So, like Kevin said, we want to start with a demo internally within the company. We have a daily stand-up, and we finish our stand-ups in 15 minutes, 20 minutes for about 15, 20 people, and the rest of the time is all demos. So we love demos internally as a company, and we believe it's a very strong way to showcase what the protocol or the technology is about. So Tyler, Kevin, and Colin will walk us through the code and the app like we discussed. And Tyler, are you going to share screen?
I think it's going to be Colin first with his
sorry,
demo,
Colin.
and then I'll walk through the code.
Perfect. Over to you, Colin.
Let's see if I can share my screen, my new fancy screen on the left-hand side. Here we go. Hopefully it tells me, ask me which screen I want to share. Your entire screen. Here we go. Screen 2. Wow, it's slow. You see screen 2?
Yeah, we see a split screen of the dashboard as well as the command prompt.
Perfect. That happens to be the correct screen. The other one, as I say, is like 3 foot across, so you wouldn't want to see that one. So what I'm going to show you, and sorry, I'm sort of looking at the screen over here rather than you, but what I'm going to show you is a dashboard. So if you go to adsign.com and try and get an ad sign, eventually you'll get to this dashboard and you can see your ad signs. So these are the ad signs that I got, and you can get free ones. These happen to be all free. So I'm going to get you guys to pick which ad sign we want to use at the moment, or if you want to get a new ad sign, we can say create an ad sign, and you can buy some. So if say if I wanted to have at Flutter, you can buy one, but that one had to be trademarked. So maybe I can't have that one, but maybe if I have a Flutter dev. And you can add to the bag, and you can be at Flutter dev for $100. But I don't want to spend $100. So we go to the Freematic, and we order up an ad sign. And basically, what this does is just a robot that creates ad signs. So we hit the compute button, and there's actually a filter up here. You can select which things you like. So tropical, music, natural. It's because I've got music selected. Let's just hit animals, get rid of music. And try again. Broad 11 octopus. Anybody like that one? Or do you want to try again?
Looks good.
That one's good. You like that one? All right, we'll add that to the bag then. So remember, broad 11 octopus. Let's compute another one for the demo. 90 ant like that sounds boring. Combined leopard. Sort of like that one. Everybody else agree?
Yep.
Yeah.
What do you want to do? Yeah, you like combined leopard? All right. All right, so we'll add that to the bag. And you can do this yourself. It's no big deal. And we can, I guess we can check out. Just click the checkout button. And yay, it's $0. And you've got to prove yourself human, so you've got to slide this into the bag. And I've got to verify my email address. That's going to come through in an email in a second. It's a little dull having to do this, but yeah, whatever. That's because I wasn't. I'd left this up and running, and it wants to make sure it's really me. So I have my verification code comes through on email. Hit Control C. Put in here and confirm. And yeah, it's mine. So broad 11 octopus and combined leopard. Hit save. Yay! So we go back to the dashboard here. We will see my @ signs, and we got broad 11 octopus and combined leopard. So let's just put those in a notepad because I will forget them. So broad 11 octopus. And the way these work is, although this is the @ sign, we're going to put some data behind it in a second. If you're a developer and you actually want to see what's going on, sort of behind the scenes, how the actual platform works, is what it's nice to do is actually run the microservice on your hardware so you can see what's happening on the microservice. So everything here, the @ sign itself runs on your phone, the application runs on your phone, and there's an SDK, obviously a Flutter SDK that you build your apps against, and there's a bunch of widgets you can just steal. In a minute you'll see a chat app fired up, and Tyler will take you through how the chat app works. But essentially it's a app that is made up of a single widget, and the single widget knows how to talk the underlying platform and protocol that goes on underneath the skin. But the great news is you don't need to know any of that. You just need to know what two @ signs want to chat and what they want to chat about. You can deal with that, and the platform and all the underlying code and infrastructure will deal with all the encryption keys and all that good stuff. And you'll see that in action in a second. But what we also offer is, if you wanted to, let's just do this one. That's digital GNU. So that's another @ sign. And to be able to use it, I have to activate it. So although I have this @ sign at the moment myself, I have to activate it. And what activation means, and we might as well click it, is it will run a microservice on our infrastructure. So it's not going to cost you anything. It runs on our infrastructure, and once it's set all up, it will actually give you a QR code that you can scan with an app, and that will bind your phone or your device with that microservice. And it's bound in such a way that you actually have the keys. Your phone develops actually cuts the cryptographic keys, and those cryptographic keys, the public side of those cryptographic keys get sent to the microservice. And only somebody with the private keys, and that's you because it was cut on your phone, can actually access that microservice. We can't, although we're running the infrastructure, we can't. So that takes a few minutes to cut the keys, get DNS up, get cryptographic certificates and all that good stuff in place. And eventually you'll see a QR code up here. So that's great for 99% of people that are using. So there's a QR code, and you can either save it or scan it, and your application will come up and running. But we're really into things that are fully distributed. So why can't I run my own microservice is a pretty reasonable question. If I'm running my own microservice, then I can see what's actually running on that microservice. So I'm going to run you through how to do that. We actually have a repo, and this is a repos in the @ sign Foundation. It's obviously on GitHub. It's called DES. DES is a distributed edge secondary server. So these microservices we call secondary servers. And there's a bunch of instructions on how to set it up. So what sort of machine do you need to run a microservice? Or a very small machine. Actually, it's way smaller than Amazon will even give you. But what I have done is logged into Amazon. Is everybody familiar with running a virtual machine on AWS and Amazon? Everybody comfortable with that? Yeah, I see some nodding, so everybody should be comfortable with that. All right, good. So what I've done is set up two virtual machines that we're actually going to run these microservices on. So if you see here, we've got one in Oregon, because I know somebody's in Oregon at least, and Kevin comes from Oregon. And if we go to London, where I'm from, I can find London. It's there somewhere, London. We have another virtual machine running in London, and it's called London, strangely enough. And I actually have these two virtual machines over here. So there's one virtual machine and there's the other one. And yeah, strangely enough, the one at the top's called London, And the one on the bottom is called Oregon. All right, good. So these have actually got absolutely no software in at all. So the basically brand new virtual machines have got nothing on. So this first thing really is a good idea to do is the apt update. They're running Ubuntu, so we actually support Ubuntu with the DES stuff at the moment. And
hey, Colin, if possible, could you increase the font size?
sure thing. I'll tell you what I'll do. I'll change. Change the scaling. How about this? Is that better for you guys?
Yep.
All right. So I'll close the window now a little bit. So we have to run apt update, and obviously you've got to run that as root. So sudo apt update, and that basically updates all the repo information. We'll do it on both machines. And that takes a couple of seconds, and I'll put the instructions. They're all in DES, but if you go to the DES, there's instructions or MD, and we'll just do exactly what it says in instructions MD. And the first thing it says is, sudo apt update. That's good. Actually, Git is already installed on AWS machine, so we don't need to do that. But the next instruction actually pulls down this repo. So we can just copy this and paste it into here. That will do the Git clang for us. You can see it's not very big. This is in Oregon now. And the next thing it says is cd into the DES directory. So there's a directory here called DES. DES. And cd DES. And you'll see there's a bunch of scripts in here, and it's extremely complicated. All you need to do is run the install software script. So what install software does is gets the environment all up and running on Ubuntu. So we actually, to run the microservice, you need a whole bunch of stuff, and it's really boring to give all the instructions. So this mostly runs through a script that installs all that stuff and installs. We use Docker in swarm mode. As people come across Docker before, I would imagine you guys devs, so you've probably used Docker before. We actually use it in Docker swarm mode. There's a reason for that. In that, if a machine goes down, a virtual machine goes down, you can add to the swarm, and your service will automatically migrate to another one. So it's sort of good practice to run in swarm. We've got a swarm of one node, but it'll work. But it's nice to have maybe 2 or 3 other microservices if you're really worried about it. Well, the other thing you'll notice is it does say ARM64 here. So I know you see this. It's installing ARM64. So we're actually not installing this on a AMD or x86 box. We're installing on ARM 64-bit. The Docker container has got a entry for ARM64 and AMD, so you can run this on a regular PC or a Raspberry Pi. I just happen to have one over here, and it runs just fine on our Raspberry Pi. So if you want to run your microservice at home, you need a machine to run it on. Raspberry Pi is as good as any. I'm using a Pi 4 here. You can run a Pi 3 if you want. Just run Ubuntu, and then just basically cut and paste the same the Git, and the script will deal with everything, install everything. So you can see that both machines now have got Docker installed, and it's set up, and there's a brand new user called the @sign user. So that's all good. That looks like a good thing. What it's now saying is you've got to run the create script. So let's run the create script. And this will actually create the microservice. So the first command was basically getting everything in place. And we'll do the create script. And if we just hit return on it, it will tell you what you need. So this is in London. So we've got create sh and then the @, the DNS fully qualified name. So we've got to have a DNS entry for this machine. The port number that the microservice is going to listen on. The email address you're going to use to get the certificate. Every microservice has its own SSL certificate. And then the service name. So generally it's the same as Bob. Service name is the way Docker in swarm mode keeps an entry for you. So let's create a microservice. We have two @. We have broad 11 octopus and combined leopard. So can we put the octopus in London, or do you want the octopus in Oregon? Preferences, please.
Octopus in Oregon.
Octopus in Oregon, yeah. All right. So in that case, that means that we are going to run this script here, and we're going to have the combined leopard over here, combined leopard, and we need our fully qualified domain name. Now I just happen to have created. Whoa! I happen to have created a domain name. You can do this with Route 53 on AWS if you like. It's nothing particularly clever. Shadoof.com, that's my domain. And this is my email if anybody wants it. And we're going to put this on port 6464. So obviously when you set up the AWS virtual machine, you need to have port 64 open. It also needs port 80 so you can get the certificate. And we are going to call this combined leopard. So what this is, create the @, the fully qualified domain name, the email address to get the certificate, the port number of the microservice is going to listen on, and what the service name is. So let's hit return on that. And it's saying the port range isn't in there because I didn't put the port number in. So fortunately, our script is very clever and told me I didn't put my port number in. If you look at this, it says fully qualified domain name and then the port number. So we didn't put the port number in. I'm going to use 6464. Why 64? Because 64 decimal is an @, so that's two @. So I put the 64 in the wrong place. Let's get rid of that. And this should work. There you go. So it's setting up a certificate that uses certbot. If anybody else has ever created a certificates using certbot and let's encrypt to get a certificate. It looks like it's got the certificate. And you will see a QR code, a very large QR code because we've expanded the scene. So this is the same QR code as we saw in the UI, but it's obviously not exactly the same as QR code. It's actually a secret. It's a shared secret between this microservice who spat out this QR code and your phone. So we'll see in a minute when I bind the phone to these things why you need the QR code, because nobody wants to type in that long number in there. If you want to scan it, if you've got a QR code reader, feel free to scan it. And you can see it's just the @ and then a very, very long number. So we need to do the same on the other machine. So that's London. And we do a /create. And we can see the arguments. So this time it's the octopus. Get my mouse to the right window. So I brought up octopus and I put DNS entry here. And we'll use the same port number. And my email address. And then we'll call the service name broad octopus. Alrighty, I think that's all we need. So it's going to get the certificates. Looks like the certificate was been requested. Hey, we got a certificate. That's good. And we are up and running. So let's just sudo docker service. And then ls. So this will list the services on this machine. And you'll see actually two services, and looks like they're both running. Let's just fire out that. So there's a service running. That's good. And we do the same one here. So these are the microservices that are actually going to answer the questions. Yeah, it looks like this one's up and running as well. They're both on port 6464, and we've got 2 QR codes. All right, so the next thing is, let's see. So this is the backend service, but let's see if we can pair them up. So I'm going to create a duplicate session on this one. I'm just going to put these ones out of the way. I'm going to scan the QR code in a minute. You'll see that in a minute. That's on my other screen. So here's the London machine. And I'm going to use this one over here. Duplicate the session. And there's Oregon. So what we're going to do now is just tail the log file, because it's always good to tail the log file, right? So Docker service ls, we know what the ls logs -f. So this will tail the log file, and it's called Octopus secondary. There we go. So we can actually cut and paste this one. So this is basically the let's just combine the left. This will look at the logs of the microservice, so we can see what's going on when we scan that QR code. So what we need now is a couple of phones, and it so happens I have a couple of phones. So there's one, and there's the other. So can you see those 2 devices okay?
Yes.
Okay, good. So we have the application. You can see we've been playing with it. So it's an app chat application. So we're gonna chat across these microservices. But the first thing we've got to do is bind ourselves to one of these microservices. So I'm going to use my phone. The other one's a tablet, but the one I'm running at the moment is a phone. And because it's my phone, I'm going to be combined leopard on this one in London. So this will go to London. So it'll say, let's go, and it'll say, enter your @ sign. So we know it's combined leopard. And when this, obviously this thing knows nothing about the microservice, it's going to actually speak to our platform and find out where combined leopard is, i.e. the DNS location and the port number. But yeah, how does it know that stuff? We haven't told it. So let's tell it. So let's just go to our web browser, and here we are. So we've got combined leopard here. Obviously we haven't activated it because we've got our own microservice. If we activated, we'd run on sort of an @company microservice, but we want to run our own. So we've also got to tell the system where this is. So you go into your @ sign, you go into advanced settings, and the fully qualified domain name we know is london.shadouf.com, and the port number is 6464. And now we can activate it, but on our own microservice. There we go. And on Broad Octopus, and did you see that? There was a little flip in the log file there as we activated it. It's obviously just making sure that it's actually up and running. So let's look at Broad Octopus, and we'll look at this log files. See if you keep an eye on that as we activate it. So, oh, we didn't want to do that. We didn't want to click that one. What that's doing is creating a microservice on the, what I wanted to hit was manage. So let's see. I'll wait for this to finish, and then I'll deactivate it, which is probably an interesting thing to do anyway. So this is firing up the same microservice, but on our infrastructure. And we don't want to do that. We want to manage it ourselves. So let's just wait for this to finish. It takes a few seconds because it's got to put in a DNS entry, get a certificate, and then spin up the microservice. So it does take a few seconds. Sorry about that. I clicked the wrong button there. Okay, so you see this QR code? That's the same sort of things we saw in the ASCII terminal. Let's go to manage now. And what we want to do is actually delete all the data because I made a mistake. So we want to stop that microservice. And we can do that by saying, yes, delete all my data. And that will take a second. And that will just shut down the microservice. So let's go into here again. We'll hit manage, not activate. Advanced settings. And this is Oregon. .shadoof.com, and it's on port 6464, and hopefully we'll see activity in this log file over here when we activate it. Let's see. Oh, I did. I saw activation. That's good. So now the platform knows where Broad Octopus is, and it knows where Combined Leopard is. So you'll see if we go to our list of @ signs, my @ signs. You'll see these little things here. These are self-hosted. If you're using our hosting, then you'll actually have this shield come up and it'll be orange. So if we go back to this mobile device and our application, so this is Combined Leopard, which will be the top machine, and we're going to hit submit, and it should say scan your QR code. And now you can see my big, screen. That's why I couldn't share the screen earlier. And there happens to be a Combined Leopard QR code up on that screen. So it's scanned that QR code. What we're doing now is the spinning is while it's cutting the cryptographic keys on my phone. So it's actually cutting the cryptographic keys. Once it's cut the cryptographic keys, I put the secret key in the keychain on the phone, and it will upload the public side of that so I can log back into it. And I actually check to see we can log in. So these are keys that are cut on my phone, and I'm actually going to save them to my phone as well now. So I'm going to hit save. It's going to ask me where to save them. I'm going to save them to my G drive because that seems like a reasonable idea. And in my keys folder, so hit save. And then we can hit continue. All right, so this is our chat app. It's a really simple widget. It's going to ask me who I want to talk to. But let's fire up the other machine and get the other one up and running. So let's go on this one. And this one is Broad Octopus. No, Broad 11 Octopus. Broad 11 Octopus. Submit. And it asked me for the QR code. I've actually got the other QR code up now for Broad Octopus, so hopefully it sees that. Yeah, it's seen that. So again, it's creating the cryptographic keys. Probably be fast on this machine because it's a pretty big tablet. So save this, and I want to save it to my G drive. Same place, and then continue. So I'm Broad Octopus on here. I obviously want to speak to Combined Leopard.
Colin, did you want to enlarge that screen for us? If you
Yeah,
can?
I can do that. Yeah, sorry. See what we can do.
Oh yeah, now we're cooking. Thank you.
How about that? Even better. What I wanted to do was see whether we could get, see if we can get those log files going over the top. All right, so you can see a little bit of it. Let me just so I want to be talking to Combined Leopard. Thanks for that, Tyler. And done. And then I've got chat options, and I want to go navigate to the next screen, I guess. No chat history. I guess I could say hi, but let's fire up the other one. So this is Combined Leopard, and it's me talking to Broad 11 Octopus. And the chat option, I'm going to go, we could navigate to another screen or just go to full screen. I guess we'll go full screen. And You can see all the what did I do wrong, Tyler? Did I do anything wrong or not?
I don't know. I think sometimes the first message that gets sent through doesn't really like itself. So I always send a second message, and that typically goes through.
Oh, interesting. I've never seen that before. See if I can get this screen up. I see 2 messages. Oh, there you go. I got the messages. So now we have encrypted chat going both ways. There we go. Across a protocol, and it's running our own microservices in the background. You can see them whizzing around. You can see all the stuff, and send another one. See if it gets across. It's getting across and it's working fine. So there you go. You have an end-to-end encrypted app running on your own infrastructure, so you can see what's going on, and it's just working. Now we're going to show you, unless there's any questions, the 3 magical lines of code that actually do that. So the setting up takes much longer than it does writing code, and obviously you don't have to run your own microservice, but it's nice to actually see the log files when you're debugging. It's actually quite nice to see the log files, so you can see whether it's authenticating or not, and you can actually see all the microservice data, and you'll see that there's no data that's that's in the clear. Everything here is actually being encrypted with AES 256. So yeah, that's it. Tyler, would you like to show the code, or
I would indeed.
are there any particular questions? I guess at this point.
I actually have. I guess I have a lot of questions, but I'm kind of curious on how you how do you generate the encryption keys on your phone?
Oh yeah, no, that's a great question. Yeah, so we're using a great library that actually came from the JavaScript world, and in JavaScript world it was called Bouncy Castle. In Dart world, it's called Pointy Castle. So we didn't actually write any of the cryptography at all. We're definitely not that smart. That takes years of mathematicians and what have you to get that stuff done. But what you're actually seeing here is the QR code essentially is just a random bit of bits. It's a nonce. But once you've got that shared secret in place, your phone actually cuts 2 RSA keys. So the RSA keys are like a key pair, private key pair. They're 2048 bits long, just like a certificate. One's for authentication and one's for encryption. The authentication one, the only thing that ever sees the private side of that is the microservice. It's never shared publicly. But the encryption key is shared publicly, so the public side of that key is shared. And what's actually happening is RSA is no good for encrypting lots of data. It's not a cipher you can use for encrypting lots of data. So that RSA key pair gets used to encrypt an AES key between 2 people, two @signs, and that AES key is encrypted with your public key, which means that only you can decrypt the AES key because you're the only one with the private key. So it's really sort of 101 cryptography. We're not breaking, there's not any new science there at all. What we have done here is wrapped a protocol around it, a network protocol that can guarantee that you're speaking to the right person, they've got the right keys, and they have to prove it before they talk to it. That's why you see a wee bit of latency, because every one of those sessions is being tested and probed to make sure it really is the right person with the right keys before they can send a message. Did that help?
Yeah, I think. Do you have any article or blog post that kind of explains this? I would be really interested.
Oh,
Right.
Tyler's
There you
a
go.
master of doing that. Yeah, absolutely.
I do have a quick question. If it's a key is stored on the device, I mean, is there a redundancy built in there somewhere? Like if I break the device, if someone breaks their phone,
Yep.
What's it look like trying to recover or get it back into your data? And what do you recommend in order to kind of fulfill that requirement?
Yeah, it's a great question. Yeah, if you lose your keys, we can't help you. That much I can guarantee. So that's why we tend to drop the keys onto a Google Drive or an iDrive. So it goes to multiple devices. And some of us who are very paranoid like me tidy up that key and put it on a couple of devices in my house and somebody else's house. So the interesting thing is that the easy way to deal with it, though, is to run. We've got another app called Wavy, Antti was showing you. Run Wavy on two machines, two physical machines, and the key is stored in the keychain, so you can always recover the key from the other device. So if you lose a device or smash a device or whatever, then yeah, so it's good use of an old iPhone or an old Android device to store the keys on that device, and if you do lose them, you can recover them. And you actually need the keys not just for that device, but every app you're going to. So every app needs to have those keys. So, but a great question, Calvin. That's yeah, very good question.
I guess, Tyler, over to you.
And I've got a question for the crowd afterwards, so we'll have to go back to the question. But Tyler, let's see the code, because I think that should hopefully bring everything into focus.
Let's see. Can we all see my screen?
Yep.
I can.
Okay, good. So I have an emulator here melting my processor in the background, so we can kind of go along with it. How does this size look? Is the size okay?
Maybe if you can increase the scale just a little bit.
Just a little bit?
Yeah.
How's that?
Yeah.
All right. So let's get my emulator up. So there are 3 screens that Colin showed you. And just another note, Colin said it earlier, but if you want to set up an @sign, you don't actually have to go through all of the AWS steps, because I'm definitely no AWS or CLI wizard. So don't worry about all of that if that's a little intimidating. But we're going to get straight down into the Flutter code, because that's what we're all here for, right? So we have 3 screens. Very basic stuff here in the beginning. We just set up of course, our widgets, our stateful widgets. You'll see a lot of app platform dependencies that we're importing from packages. I'll show the pubspec.yaml a little bit later. But let's scroll down a little bit. You'll see a few variables here that we're initializing. We're going to see them a little bit later. We are getting the instance of our client SDK service. Colin touched on that a little bit. We go straight into the UI, what you're seeing right here on this emulator. And here is the good chunk. This is the stuff that we like to bite into. Let's see if I can bring that a little bit over. Oh yeah, all the way is fine too. So we have what's called the onboarding widget. This has a few parameters, such as the context that we just built not too long ago, the @client preference, which is all of the information of the @sign that we want to actually sign in with, and our root domain, which is our production level, which would be root.@sign.org. And then, of course, the app color, which is our famous orange. And then we pass in value, which is just the @sign that we want to authenticate with. And I can show you here in the logs that because I've already uploaded my QR code, which is at Rubber Cart Racing there, it already has my @sign. So that's passed into the @client service map, which is then initialized into the get instance of the client SDK service. And this will simply authenticate your @sign for you. So you never have to worry about the actual usernames and passwords. That's a really big advantage of the app platform. You never have to store anyone's username or passwords. So of course, after we pass in the value of the @sign, and if the authentication method works successfully, you're taken to the second screen. If not, it will throw an error, and you'll see it in the logs. And that's why Colin went through the AWS steps, because you definitely want to see if it does end up in an error, what that error is specifically. So I think the rest is just UI down here, and then storing the key into the keychain from your @sign. If this was the first time, oh no, actually this button is the reset keychain, and Colin did not go over that. So I can go over it briefly. The reset keychain will take all of the keys that exist in your keychain of the emulator or your device, whatever you're using, and will simply throw them all away. And what this will do will allow you to actually authenticate with a new @sign that you just activated on @sign.com, for example. So if I don't want to use Rubber Kart Racing anymore, I could always press the button reset keychain, and I'll be able to go through the onboarding method that you saw Colin go through, where he scanned the QR code and whatnot. So we can move on. I'm just going to click Let's Go. Hopefully that works out for me. You can actually see all the logs and whatnot in here. But because I already did all that, it's going to just say retrieve my @sign right here. And we're taken to a very familiar screen that Colin went to. And let me also go to that screen here. So in this, you will find that there are only 3 functions. It's actually really hard to navigate through here when the text is so big. Here we go. So what you'll see, this app is pretty much just UI, because that's Flutter for you. Most of the functionality happens around just the buttons and whatnot. Here in the beginning, when we're first creating our screen, we're initializing a lot of the variables. The important ones are active @sign. That would be Rubber Kart Racing, and then chat with @sign. We don't need a lot of these now, because before we had a list of testable @signs that you're able to kind of mess around with and see some pretty basic functionalities of the app platform. But we're starting to move into using actual production level @signs, like what was it, Combined Leopard, or yeah, I think it was Combined Leopard, and
Yep.
Rubber Kart Racing. So let's scroll down a little bit. Let's go through all the beautiful UI. You have the active @sign saying welcome. Let's see if there it is. Welcome. And we also have another chance. If we didn't see the remove or reset keychain before, you're able to remove this one specific @sign instead of wiping your entire keychain. That goes through all of that. You actually don't have to make your own functions that say, get rid of this keychain, delete all the cache. It's actually all part of the client SDK service. If you see here, you have an await on press, where we're just calling the client SDK service, the get instance, and then a function called delete @sign from keychain. That's pretty simple stuff if you ask me. So let's scroll down a little bit more after all of this from remove. And I think it's going to be after all of that good commented out stuff. So here you'll see the on pressed, after we input an @sign, it's going to check that @sign is actually real and activated. So it will make sure that you actually have your own server running for that @sign, just like what Colin went through, or just like how you saw him actually activate it on the @sign.com to make the QR code. And it will then, I'm going to put in, let's go with Combined Leopard. I don't think I'll be able to actually chat with him, but I actually might. Colin can confirm for us.
I can flip out. Let me.
That'd be really cool, actually.
And I'll reset, and I'll.
Oh, I gotta put an
Want to speak to Rubber Kart Racing or something like that?
That'd be really cool. I don't think we've ever tried that yet.
Rubber
So here it's going to check after I navigate to chat screen or open chat in bottom sheet. But before I do click those buttons, we have two functions that are set @ to chat with and initialize the chat service. So here's the check for the valid @ that I was saying earlier. Once you throw in that @combined leopard, it's making sure that there's actually an @ that's activated with that same string. And then it's going to set the @ to chat with. And what we need the set @ to chat with is to be able to actually initialize the chat service. Now, this is the famous 3 lines of code. Most of this you would just notice is UI. You don't really need all of this if you didn't want, but come on, Flutter is for the beautiful app design, right? So here we have a function called get @ and initialize chat. We're passing the, again, client SDK service, a function that's built into the app platform, get @, and that will get the currently authenticated @, which is me, Rubber Cart Racing. And we're going to pass that into a string called current @. We're just going to set the state because we like to have things like welcome to whoever's authenticated in, things like that. And then there is a function called initialize chat service. And you'll see I'll close that or minimize the emulator. Again, the client SDK service, very powerful here on the app platform. We are getting the @client, and we're getting the active @, which is Rubber Cart Racing, and the root domain, which is root.@.org. That, again, the production level of the company. And that's it. That will initialize the chat service. And after we do that, after we initialize the chat service, we want to actually set the @ to chat with, which is combined leopard. So we're passing combined leopard into set chat with @. So again, you don't actually have to make all of these lines of code that's setting up, chatting over some server, and then you have to make sure that the messages are encrypted. So with the app platform, this is it. All of these 2 functions here, pretty much all you need. Everything else is taken care of for you. The actual chatting itself, the encryption, everything. So once I navigate to chat screen, which is our, oh, no way. Get out of here. Anyway, as you can see, Colin has already said hello to me. I will say hello back. What a wonderful surprise. And let's send it. And here, this is my favorite part of the @chats. This is my favorite part, where all you have to do for this chat screen is call body::chat screen. You don't even need all of this. I could comment this out and the app will be more than happy to work. What you'll see is just, again, UI stuff where I'm saying, what's the height of the text, or what color is the text, and is it its own screen? So all you need is body::chat screen, and it'll work. And here I am talking with combined leopard. That's crazy. It works perfectly fine. That's cool. It's the first time I've ever actually seen it work too. So that's exciting. And that's it. I can show the pubspec.yaml to show all of the dependencies.
So I have a question. So
Sure.
when you start a conversation, are you creating a new microservice every time? Or you just create it once and then it's just assigned to the phone you're using?
Yeah, so the microservice is assigned to the @. So the microservice is dealing with just combined leopard in this case. So as I put in that message, this message went from California, where I am on my phone, to London, where the microservice is, and then from that microservice, it notified Tyler's microservice, which is I'm assuming you're running on the infrastructure, right, Tyler? Yeah, so you're running in Ohio. That's where their microservices are running, and they're running in a Google GCP data center. And then they went to wherever Tyler is in Canada and popped up on his screen. So the microservice basically is your your presence on the internet when your phone isn't offline, it can have the encrypted blobs already. And when somebody comes in and they want some data, they can have the encrypted blobs. But the actual encryption itself happens on the endpoints, your phones, because you're the only one with the keys. So it's just like a your own personal cache.
Is it possible to use the @sign in two devices? And then what happens then?
Yeah, you can use the same @sign in two different devices. That works just fine, and you get the same messages replicated to those two devices. Yeah, that works just fine.
So you're gonna.
That was Kevin. Would you like to talk about sync for a second?
So yeah, so it can work on multiple devices, so phones, tablets, watches, laptops. So it's one of the things that we love about Dart and Flutter is that you get the cross-platform support. So you can run, and you have to have a copy of your keys and the keychains on those devices. And there's good library support with Flutter now. We're using the biometric security library for storing keys or storing data in the keychain on whatever respective platform that you're running. So the challenge is, how do you sync that data between all those devices and keep it up to date? That's no easy feat. And so we actually copied the GitHub commit ID kind of model. So anyway, that's our kind of core for keeping everything in sync. So there's a commit ID, and there's a variety of different techniques that people can do from an app perspective on syncing. So you can either notify, which is like a end-to-end encrypted push notification. So it doesn't use Google or Apple push, but it does the same thing. It actually generates a push notification to the other device. And then and on the sync side, if you want to synchronize, it'll synchronize. You can either do it as a cron job once a day, once an hour, or you can do it right now if you want to force a sync right now. So there's sync now, and then there's an algorithm for queuing up sync or the commits basically, and they actually operate in a queue, which is pretty sophisticated. So it's a combination of a time-based queue and I guess size as well. What was the other?
Priority setting.
Yeah, priority and time. Both are operated on the queue, and that will keep all the devices in sync with each other. So you can change anything anywhere, and it'll sync with everything else, and you have to do nothing to make that work. So the phone basically phone originates the data, and then it's synced off to the microservice in encrypted form. And the encryption means if I'm sharing with Colin, then the encryption is me encrypting for Colin. So when it's there, the only person that can read that data is Colin. And the only person in the universe that can read it is Colin. So it's uniquely encrypted for the recipient. And then the other side is, so the chat messages you see are a combination of messages that are created by Tyler that are pushed to Colin's phone, and then the messages from Colin that are pushed to Tyler's phone. So the ones that Tyler sees from Colin are basically cached on his phone, but not stored on his phone per se. It actually operates as a cache. So if Colin says, I'm going to delete it, the message, then the protocol will make sure it's deleted from Tyler's phone, whether Tyler likes it or not. So Colin has control of his messages, and Tyler has control of his messages.
What is
ahead.
What is the TTL for the cache?
So it's completely user configurable. So the developer can decide what the TTL is and offer that TTL up to the the person using the app or not. So that's the time to live. There's actually three interesting timers, I guess. So one is TTL, which I guess we're all used to. You've got a record and it's going to time out after a while. The other one is TTR, which is a time to refresh. So in other words, you can keep this record, but it's going to time out, and you have to refresh every so often. So that's particularly useful for some data that's is going to be updated on a regular basis, and you want to make sure that everybody's got the latest copy. Or there's a couple of use cases there. But the most interesting one, which is invented, I mean, literally invented and patented, was our engineer in India, Jagan. He said, "Why can't we have time to birth? If we've got time to live, why can't we have time to birth?" And the use case there is just fascinating. So what if you preloaded a bit of information onto everybody's phones, but they can't actually see it until a predetermined time? Now you think, well, what would that be useful for? Well, it'd be useful for any number of things. I come out of financial services, and one of the biggest use cases for that would be for research data. So when research data gets published, if you're on the front of the list, you can trade on that research data before anybody else. But what if it had been sent out there and everybody gets to see the research data exactly at the same time? That's a bit of a game changer for the research business. So, big shout out to Jagan to even thinking that up. But he thought it up, engineered it, and we patented it in his name. So.
Looking at the SDK, it sounds like, correct me if I'm wrong, that the use cases are primarily for phone, and this wouldn't work for a web app or a port of your app to the web. Yeah,
the protocol, the underlying protocol itself is not HTTP. It's a brand new protocol. It's called the App Protocol, and there's a couple of really good reasons for that. But probably the primary reason is there's so much history in HTTP that it's a bit of a mess. And we really want to have a really simple protocol that does really simple things. So if you're interested in protocols, the protocol is actually as simple as we can make it. If it's complicated, we push it up to the application level. If it has to belong, if it really, really has to belong in the protocol, it goes into the protocol. But at this point, most things do not go into the protocol. They go into an application library or a Flutter widget or both. So yeah, the protocol really was the game changer. But obviously, the downside of not using HTTP is the fact that it doesn't fit nicely into a browser.
Keys as well. You wouldn't be able to store keys if you were to hop over to another browser.
That was the secondary thing. There's no place to store keys, and in the browser high-level concept is there's a server somewhere and you're a client. And I think that's old. I mean, that's been around for, 30 years, 40 years, longer. Client server, right? So you have a big fat server and all those clients log in, and clients don't need to be very powerful, and the big fat server is really really big and powerful. So frankly, we don't want big and powerful servers anymore. That's sort of crazy. We have a pretty powerful server in our hands. So the paradigm we use is your client and server at the same time. So everybody has a server. Your microservice is a server, and sometimes it's serving stuff, and sometimes it's a client. So you have to be a client and a server at the same time. I think that's the new paradigm for new protocols. And sure, we could have welded it into HTTP, but it would have been a mess, and mess equals security problems, so I didn't want to go there. But the downside is you can't lift any of this code and put it in a browser. It simply won't work. But it works fine on a laptop. It works fine on, so we've got some apps being written at the moment for other platforms. But yeah, we started off with Android and iOS, obviously.
So for browser, I mean, one thing that could be done is having things like a server-side rendering where the backend speaks TCP/IP. We actually have an example of that in the server status library. So it's got a really stupid simple web server that it's a read-only web server. So there's no puts or updates or posts, but it'll do a get, and so it'll actually go out and use TCP/IP protocol to talk to a NAT server and find out what its status is. So that's, a server-side rendering model could work. We haven't spent a lot of time there. We do have a thing that we're working with another GDE that Randall knows quite well to do a thing called @login, where you could actually do equivalent of kind of single sign-on, but truly no passwordless single sign-on, and so that'll allow you to log into a web app. That's about as far as we're comfortable going at least at the moment. We are thinking about doing like a browser extension or something, maybe. But that's again it creates too much risk, we think.
That's fair enough.
So Randall raised his hand. So
Randall.
Accidentally, sorry, pushed the wrong button. Stupid UI. I thought I was saying hi to myself. I guess that isn't what that means.
Hi, Randall.
Hey, Randall. I was hoping for a normal Randall difficult question. So we like difficult questions. We learn a lot.
Any other questions?
Well, see, now that's a challenge. So when will this all be done?
It never. It never be done. Perpetual beta. Would you guys like to see what you can actually do with it? I mean, we showed you a demo widget.
Yeah.
Would you like to see what is the art of the possible? What that application looks like?
yeah,
Sure.
Alrighty. See if the demo gods are with us. I'm going to do it with an iPhone, I think, as well this time. So obviously we're 100% focused on the platform. We've done some apps just to demo apps, so people like yourself can get going. But we've had a couple of developers that have been working on this pretty hard for a long time, and they've been doing the journey with us. And one of them is called App Buzz. So that's the name of the application. I think on Android actually it's in the store, but on iOS you've got to. Let me just finish this one for a second. You've got to go into. Is it in test flight, Kevin? I can't remember.
It is in test flight. Yeah.
Okay, so you can get access to it, but you have to go to test flight. So it's at Buzz. Let me just share this screen again. My entire screen. That one. Shout when you can see it. Can you see that okay?
We can see it.
Alrighty. See if I can get screen mirroring work from the there we go. So you should see an iOS machine on the right and an Android on the left. Is that what you see?
Yep.
Alrighty.
Yep.
So one of the things that Kevin and I thought about was which app should be the first app, and Kevin came up with a great question, which is what's the worst app on your phone? So what's the worst app on your phone? I can guarantee it's the same worst app with everybody once you hear what it is. No guesses? The worst app on your phone. It's Contacts. Yeah, Contacts app is definitely the worst app on your phone. It's never changed. It still looks like a file of fax. And just like a file of fax, nobody updates their contacts in your file of fax because it's your copy of their data, which is sort of stupid, right? So keeping a contacts list is ridiculous because whenever you go to use it, especially if it's an old contact that you're not in contact with very often, it's going to be out of date, and then you're going to be scrambling around on LinkedIn or phoning up friends to find out, Chuck's phone number or whatever. Happens to all of us. So the idea is that if we had our platform up and running, this is like 2 years back before we'd written a line of code. Wouldn't it be great if you could have a contacts app reimagined where the only contact you had to look after was yours, and everybody else looked after theirs, and magically they could share things that they wanted to share with you. And that's essentially what the Buzz team have come up with. Just like before, every one of these people have had their @sign, and I'm going to fire up on both machines. And you will see Both of these people have @ signs. So on the left, we have Responsible Plum, that's Cheryl. And on the right, we have Japanese Dove 9, and that's Alice. And Alice is Cheryl's daughter. So what would you reimagine in a contacts list? Well, I don't want to share the same contacts with everybody. I want to share different information to different people. And I can do that through what we call personas. So there's a bunch of personas here. And the personas are sort of different aspects of Alice's life. So she's also a photographer, she's got best friends, she's got boring contact details, family and work. And these are different views of her life that she can share with other people once she knows their @ sign. So let's look at one like family. So this is the data that she's sharing with people in her family. And that down the bottom is Responsible Plum and selected Kingfisher, her mum and her sister. And, there's sort of not just contact details in, but a whole bunch of other things, birthdays, what have you. And also things that you should never share on the internet, like your Wi-Fi password. Wouldn't it be nice if you could change your Wi-Fi password and everyone in the family got to know your Wi-Fi password? That would be pretty neat. And of course, with the Buzz app, you can do that. It's really down to your imagination, what you share and with who. So you can create a persona. Let's look at a couple of the other ones. There's like besties. So best friends, sharing it with me because I'm one of her best friends. And other people can share different things. And because the protocol that underlies this knows who's asking before they get the details, we know that only the right people are getting things. And if we want to add somebody, so if we want to, this is my bestie's friend. I've got a new best friend. Let's say it's that guy called Kevin. We can click Kevin, and now Kevin has the best friend information. So if Kevin went into his profile, he'd actually see that information pop up. And if we change our mind, that Kevin guy is driving me nuts. I'm on my best friend anymore. I just click this button here, and that information just disappears from Kevin's phone. And there's nothing Kevin can do about it. So just like the chat sort of thing, this is sort of data going between two places. Let's have a look at Cheryl's point of view. So her personas are way more simple. So just contact details, kids.
You're such a tease, Colin.
Huh?
You're such a tease.
I know. Sorry. I shared data. You went to look at it and I just took it away. I'm sorry.
Yeah.
So she's got a kids persona. She's also shared that with kids. And just to show you what the other side of this looks like. So we're going to favorites. There's obviously Alice's mum. She's short-coded as mum. And you can change that stuff. You can edit it. You can have notes and nicknames and what have you in there. And we can look at mum, and away you go. So we can go into here.
So I kind of want to compare this to, let's say, you're using WhatsApp for sharing information, right?
Exactly right.
And with using ad platform, nobody's gonna get your data.
Correct.
But with WhatsApp, they're on the other end of the spectrum where they're gonna want every piece of your data for advertising purposes or.
Yeah. So WhatsApp is actually end-to-end encrypted, and believe it or not, WhatsApp actually uses a protocol from the Signal. So WhatsApp actually uses the Signal protocol underneath the skin. But there's a huge but with this. All of that communication goes back to a big server, whether it's the Signal server or whether it's the Facebook WhatsApp server. It all goes back to the server. It's still client-server based. So the server can then not look at your data because that's end-to-end encrypted. But what the server can say is, Sid's talking to Kevin, and Kevin's interested in ponies. So probably Sid's into ponies as well. So we're sent to pony advertising. So it's not just the data that needs to be encrypted, it's your network connectivities. So I'm sure we could look at if everybody in the world was using our infrastructure, we could see data is going from one place to the other. But even that, if you're running your own infrastructure, like we fired up that microservice in AWS in London, the only person that can see data that's going in and out of that microservice would be the person running that microservice, i.e. you. Or if you're running on a Raspberry Pi at home. So there's no way of getting that metadata. It's completely distributed. The only thing that's centralized is the what we call the root server, and that holds the directory of what @sign is where. So that data we put in, like the fully qualified domain name and the port number, that's the only information that the root server has is just that. So yeah, and you don't need to authenticate to do that. You just need to speak to it as a service out there. So the difference between what existing platforms do and what we do is the fact that, okay, it's all end-to-end encrypted, but it's also unsurveillable. It's completely distributed. All of those endpoints are all distributed, and even we can't see who's talking to who.
It's actually interesting that I don't think I knew WhatsApp used the same protocol as Signal.
Yeah.
And I thought end-to-end encryption meant that even the servers cannot see.
Yeah, they can't see the data. They definitely can't see the data, but they can see who's talking to who. So it's what they call the metadata.
Metadata, right? Okay.
Yeah, so if you were speaking to Calvin, they would be able to see the conversation, but they would know that 8 o'clock every morning, Sid and Calvin talk about something. We don't know what it is, but they definitely talk about something.
They'll probably get that from other cookies from somewhere else, and then they'll figure it out.
Yeah, maybe, and they've probably got locations. So if Sid and Calvin are talking to each other, and they're 10 minutes away, and then they're talking to each other, and they're at the same location, and the location happens to be a coffee shop, use your imagination.
Yeah. Yeah.
So that is going on.
They know your phone number, and in a lot of cases, people put your phone number on Facebook as well, right? So they can interconnect that aspect of it as well.
You got it.
Yeah.
So this is the last sort of demo. I mean, you've seen this with the chats, but let's say the COVID shot is going to be on Friday now. It was on Monday. It's going to be on Friday. We can hit save, notify everybody, and that will just do the real-time notification. And the guys did a really good job on this. Hands are up here. I didn't do anything, but it's updated in real time. So there's a provider being used. So when it gets the update, it will refresh everything. Kevin, did I miss anything?
Nope.
Sweet.
It's the only platform I know of for building end-to-end encrypted apps. So we're trying to make it as easy as possible for everybody to do end-to-end encrypted everything.
Yeah. End-to-end encrypted and surveillance-free. So, yeah. The guys are actually working on notifications list, so that's why I went to this as a feed list. I haven't got that copy yet, but there will be a notification feed, so if somebody's updated something, so you can see it. Because obviously real-time updates are great, but what happened? Well, we need to have a log file. So that's the next things that those guys are working on.
Wow, I think this is a great product. This was one of the things I was thinking about. Like, how do let's say I'm planning to add chat within my like a bigger scope. Like, it's probably people want to go for a hike together or go for camping together, and they're trying to arrange an event. But I also want to have a chat, and I was thinking about how do I create an end-to-end encrypted chat. And yeah, I mean, if I can create one using just 3 lines of code, I think that's pretty convenient.
I think you'd be happy to hear that there's an @events widget as well that you can use.
It's awesome.
And the location widget. So.
Yeah. So Kevin, I was planning to bring up our slide on hyperconnected apps. I think Sid's question is a perfect way to explain that. We have an answer for that, Sid. So you should take a look at this.
Yeah. Instead of having an app for that, we've got a widget for that.
Yeah.
So.
And there's another interesting side effect to having essentially all your data in one container. It's a in-memory name value pair database. It's native Dart called HiveDB, and it's also encrypted at rest. So all your data for all your apps goes into the same container. essentially, or can do. You can separate them out or combine them together, but you have the ability to kind of reason. Apps can reason over all your data. So you can think of interesting use cases where I want to have a chat in one place and have it show up in another, have those same chat messages show up in another app for whatever reason, or not. I mean, it works both ways, or locations, or I mean, so different apps can actually share data with each other really easily. And so in this case, we kind of have there's different apps. So at chat, that's one of our it's just a sample app that we have in the repo, the demo app. We haven't put that out in the stores yet, but there is a developer working on a professional version of that that they own. Then there's Take a Vote, which allows you to ask questions of your friends. Where do you want to go for a hike? What day? What time? And do these real simple polls. And then Arrive allows you to share locations with each other that's unsurveillable. So nobody can see what information you're sharing on location. And Atmosphere, Atmosphere is kind of like AirDrop or file share, where you can share files with each other, again, end-to-end encrypted. But it's just as easy as AirDrop on the iPhone, where you can just share a file with somebody and it'll stream it over to them. Or there's a Atmosphere Pro does store and forward on what soon will be an IPFS file repository. Right now we're using another Dart package called FileBin, and but we're pretty excited about using IPFS for storing big data, big file data. We're working on that.
FileBin's written in Go, but the dev was really excited about us using it, so he wrote a new copy just for us, which was very nice of him.
Yes, and so hopefully this answers what you had in your mind, right? I mean, as to if you're planning to get a group together, chat, I mean, all of that could be shared across the different apps, and you could do several other things like, votes or location or file sharing. So, and all of these are interconnected, like Kevin said.
Yeah, on the top there you see groups. So the other thing that this is getting groups or using kind of a set theory model for doing collections of things like people in a group. So we're looking at how to do something really interesting, I think, in how to form and interact with group data as a group. So all that kind of stuff, you can have a group that's formed in a chat that is used in file sharing or location sharing. So having a group that's accessible across multiple apps is probably one of the, I think, most important features we can, if we get it right, that'll be I think an important step. So that's one of the big things we're working on going forward.
Awesome, thank you. This definitely looks very interesting.
I love what you guys are doing. I love the idea of a platform for this. I appreciate the security going into this. I'm an entrepreneur myself, and I'm actually just curious because you have a bit of a chicken and an egg problem, and you also have this hurdle to overcome where people need to be privacy conscious enough and willing to probably pay as opposed to receive targeted ads. I'm just curious, what's the business strategy in order to kind of grow and evolve and build this out and acquire as many customers as you can?
Yeah, so the main thing, so the primary thing we're trying to do is deliver cool experiences that you don't have otherwise. So if you look at the Buzz app, I mean, it's not a big decision to download an app. If you look at the full onboarding experience, you can download the app, get a free @ sign, get going in 20 seconds, and then start sharing information with your friends, right? With your friends and family or whatever group. I mean, Colin has a number of groups that he works with. He's a Rotarian. So the Rotary group, how do you keep all those people, in up to date with each other, which is right now a spreadsheet, like everything else.
We moved from paper to spreadsheet. We're very very 2021.
Exactly. So but Buzz is kind of a really interesting new way of connecting with people, and the Wavy is a new way of a number of other options out there for creating your microsite content with all your social links and that kind of stuff. But there's between Wavy and Buzz and file sharing, and so anybody who's got does accountancy or real estate or whatever. But the point is that each one of those apps can be adopted all by itself and start to propagate out. I mean, every single one of these apps at its heart is sharing information with other people, which kind of builds lots and lots of little networks. And so our network effect is a accumulation of lots of little ones. So we're not trying to do is say we need 2 billion people on a server. What we want is lots of little 10 people, 50 people groups that are happening. And if you actually do the math on that, it actually grows amazingly fast as a viral method. If we create the right experience, if we do something that's better, so we're trying to do, here's a better experience that happens to be private, not saying here's a private experience that's painful and not so much fun.
That makes sense. I do have just one more question about the implementation side of it, because I've built an app myself, and I do have a future plan of having family-centric kind of group channels within the app for communication. But I'm still struggling with that hurdle that is like, what happens when you get a new device, or what does that look like to break a device or to get a new device and then to migrate your keys in that fashion? And if you're just sharing keys on Google Drive, then is that really, or some other centralized location, then is it really that much more secure?
Colin, you want to talk about this? I mean, so when you first set it up, you saw the Colin says you'll save your backup key somewhere, right? So that's the main area of propagation. The thing, what we're hoping to do is, and this is the way that the phone operating systems work today, is every app lives in its own sandbox. So it's hard to share keys between apps today. It was impossible, really, unless you do something like an enterprise version where you can do an app group. So we might try to leverage some of the app group features to allow apps to collaborate with each other. Then you only have one place to store the key instead of each app having a copy. But at the moment, the benefit is every app has a copy of the key on every device that you're working with it. So you have the chance of losing keys we've had a lot of people who's like, oh, I lost my phone or my key or can't remember where I put it. What do I do? And it's like, great, go, do you have another device? Yeah. And it's like, okay, so go there, within the apps, generally there's a, save a copy of my key is built in, and then save another copy and then use that to pair it up again. So it tends to be, we actually haven't had much, I can't think of anybody who's actually lost their data because they lost their key. There's usually a way to recover. But we'd like to get better at that, and hopefully the phones OSs will mature. There's a couple of handsets that are coming out that are very privacy-focused handsets that have vaults and that kind of stuff for make it easier to do this. So I'd say early next year there'll be better phones that do it better, and that'll be part of the evolution. But right now the chances are pretty low of losing your data, but you do have to take care of your keys. And then calling on the Raspberry Pi there's if you have well, you want to talk about the security side, Colin, where to put your keys?
Yeah, so I have equal concerns with Calvin. I mean, it's convenient to store your keys on a G drive and then have them. So other people suggested, well, could I password encrypt my keys? Like, I can guarantee if you password encrypt it, you will forget your password. I mean, it's just, you're much better off using the keys on a G drive and then deleting them once it's in another device. So that's all we suggest people do, is use G drive just as a transmission to get it to another device, put it on another device, and then fire up Wavy and you're done. And then delete the key, because you don't need the key anymore. It's on two devices. But we've also been working with Raspberry Pis, because many of the people that we work with are developers and security people and government agencies, and they said, well, I want to put it on a server, but I don't trust some big server. So can I put it on a Raspberry Pi? And I said, like, no, that's a really, really bad idea, because the SD card is not encrypted. So we recently been working with a company called Zimbit, and they provide a hardware enclave for security keys. And I can actually show you one. I don't know if you can see it, but there's a little blue flashing light. And that's like a little device that goes on top of your Raspberry Pi, and that hardware encrypts the keys. And then instead of just encrypting the keys, why not just encrypt the whole file system and drop your keys on there? So that's exactly what I did. That's exactly what I do. So yeah, because I'm paranoid, and some people need to be paranoid, other people don't. It depends on sort of value of your data, I guess, on how much pain you guys. I mean, not everybody has got a vault in their house. Some people, I'm sure, have, because there's different levels of value. So for me, a Raspberry Pi, $35 plus a Zimbit, $40. That works just fine. But increasingly, I don't know if you've noticed, but there's increasingly a number of startups and crowdfunding ventures that are saying, don't use the cloud, use your own server, run your own server at home. Some of them are meshed, some of them are not, some of them are standalone, some of them in a big network. So other people have figured out that there's, you need somewhere to store your data other than the big cloud. And we're not going to solve that particular problem. That's a problem that somebody else can solve. But if you are interested in that, then I can certainly give you the instructions and my experience on the Zimbit if you're a Raspberry Pi guy. But there's plenty of other options, I guess.
Thanks, appreciate that.
Yeah, I mean, so right now, I mean, the place that we trust the most is the secure enclave on your phone. That's the best place to have your keys in the world. I mean, there's no better place. And so we're hoping that will mature. I mean, the keychain are partially synchronizable at the moment between devices, and at least with and a cloud service, if you will. So that could become a much more interesting mechanism theoretically. But again, now you've got your keys there. They have your keys. That's not such a great option. And we're pretty intent that people have control of their keys forever. I mean, that's just a really important principle.
Yeah. If it's end-to-end decrypted, or somebody's claiming end-to-end encryption, the obvious question is, who's got the keys?
Yeah.
And if you haven't got the keys, then maybe it's not so end-to-end encrypted as you thought. But if you come up with any ideas, Kevin, it's an open source project. There's discussions, there's issues, post something. I mean, we know for certain that we haven't got all the answers, because there's way more smart people outside the company than inside the company, as Bill Joy will tell you.
Yeah, and if anybody's interested, jump in on the repo and help us make it better. We got a pretty good foundation by now. Sorry, Sid.
Yeah, so one of the question I have is, you depend on a lot of third-party libraries on pub.dev, for Dart and Flutter. And some of these libraries are probably maintained by just one person, and you never know when it might just die, right? So what are your thoughts on that? I've been looking at some of the metrics for provider and block architecture libraries, and even though they have 120 contributors, it's just one person who's doing all the work. And, even for some reason, the person can stop maintaining the library, and it can cause a lot of problems. So I'm contemplating if I should find a backup plan, like just try to see, okay, maybe I can just switch to inherited widgets or something like that. So, but I'm interested to know your opinion on that, because these things can easily happen.
Absolutely. We faced that. I mean, we started off using Flutter Keychain and now we're using biometric security. So I think in the end, whenever you're building whatever you're building, then you just make sure you have the right level of abstraction. So on our persistence, we've completely abstracted the persistence, so we can swap out. We use Hive on the phone. You could use Redis on a big server. You could use any persistence you want, and it's pretty easy to swap it out with something else. So I think if you architect your software properly, build clean interfaces, and then have the implementation classes, it's easy to replace something with something else in the future as you need to. We've had to do that already, and it was completely seamless. The SDK didn't change one bit when we swapped out the keychain code.
Yeah, I think you're spot on when you said, okay, you have to create the abstraction, and I do that for some of for my DAOs or for the data layer, but I haven't figured that out for my state architecture or the state management. So
if I can follow on to that for a second, great answer so far, but let me see if I can mess it up. No, I think a couple of things are important because I've had years of experience with the CPAN, the Perl public archive of data. And yes, things get abandoned from time to time. But just like on PubDev, we have pretty much everything that's there that's worth using is open source. So that's one thing to keep in mind. You can always fork it. You can always take it off and run with it. Like the whole Flutter project. Google could tomorrow go, whatever, like Angular Dart. They already have done that, and they're looking for a new BFDL for Angular Dart. But the other thing is, it doesn't stop working the moment somebody says, I'm not working on this anymore. It's not like it's going to break tomorrow. It might not be possible to work with, later incompatible breaks and other software and stuff, but it's not like it's going to stop working. So you've got a couple of layers of installation there. One, open source, you can fork the heck out of it and do what you want to it and make it your own, and maybe get a bunch of other people that are also interested in that. I mean, if Remy should go away tomorrow, Provider and Riverpod and all the other wonderful things he's created, we'd still have those, but it wouldn't necessarily be him pushing buttons.
Yeah, I think I agree with you. Like when somebody stops working, maintaining it, it's not going to stop working. But, one person working on a critical library could be a problem because there's only one subject matter expert. And even if somebody else comes in and start pitching in, you're only creating more bugs. But just because it takes more time to onboard, because it's such a great library, but also complex library.
Thanks, Calvin.
So
I got a little story for you, but another bit of commentary, I guess, on that, and encourage people to do this. So many of the people that we work with, you look at libraries, use them, but never look at the actual code behind the library. So they go to PubDev, and then it doesn't go. It doesn't work the way they wanted it to, or it's got a problem in it, and I'll move to the next one. Rather than looking at the code and saying, "Oh, I can actually go fix that," and actually become a contributor and actually raise PR and get it changed. So I encourage everybody to support the single developer that's creating an awesome package. By looking at the code, understanding it, and becoming a backup for that person by looking at the code and submitting a PR. And I got a couple of stories, but the one I really like, and Kevin's grinning because he knows I'm going to mention double unicorns.
Yep.
So Kevin and I were working on a bit of code. The database we use, which is phenomenal, HiveDB, all pure Dart. The key value, the key and value. The key is UTF-7, so it's just plain old ASCII 7-bit. And obviously, it's very difficult to put an emoji into a 7-bit, so you need to convert the UTF-8 into UTF-7 so you can have a key to put in the database. So it was my job to write that bit of code, really simple. But there's a library. that can convert UTF-8 to UTF-7. So I used that, and everything was working fine. And because I'm particularly good at finding bugs, for unknown reasons, I put in a double unicorn. So at double unicorn was the atom I was going to test, and everything failed. I'm like, hang on, it works for everything else. What's so special about double unicorn? So looked into the library, and instead of jumping library, I looked into the library. Great guy running the code, and what he'd done is actually ported a JavaScript library from 30 years ago, and put it into Dart, which was awesome. So, but the bug was not in his code. His port was perfect. He'd done every line perfect. It was actually in the JavaScript code that he ported from. So find the maintainer for the JavaScript library. And believe it or not, he's still alive. Looked through the JavaScript, found the problem. Oh, like, this doesn't work with double unicorns because of this. And pushed a PR. That woke him up. And he goes, thank you so much. And yeah, problem solved. But that stuff's cool, right? And many devs don't bother to look behind the library when they hit a bug or hit something that doesn't work and then contribute. So the best way to solve that problem, Sid, is for the community to dive in and support it. And to a large extent, that's what's happening with Angular at the moment, right, Randall? So that's supported by the community, which is the way it should be. But we all need a leader. You know, like Linus Torvalds, without him, we wouldn't have a kernel, right? And at some point, he's going to want to retire, I would hope. But maybe Linus never retires. Maybe that's what happens. We'll see.
Well,
yeah, get involved is the only and real way to deal with those issues, I think.
And that particular bug had been there for decades. Nobody had found it before.
Double unicorn was a good one. Because there only really should be one unicorn. We all know that, right?
That's right. You broke the magic.
It's pretty funny.
Awesome.
Small question answer, Sid. Sorry.
Yeah, that's I use Provider. I'm really happy with using Provider for my state management. And I was just wondering, I was just looking up other libraries, and I was also checking the metrics to see if anything could go wrong. And yeah, that was the only thing that came up my mind. But yeah, I was just thinking, okay, maybe if I can just use inherited widgets, just do an experiment and see if I can completely get rid of any state management libraries. But yeah, inherited widgets are a little tricky, and they're more like it's harder to write maintainable code using inherited widget than Provider, in my opinion.
After working with RiverPod to take a look at Provider and then to take a look at inherited widgets, it feels like doing multiplication by repeated addition. So many things you have to do by hand. That's all automatic behind a single little line in Provider or in RiverPod. Yeah.
Yeah. And before I let you all go, maybe I have one final question. Do you think Google will step in case a major library is not being maintained? What is your opinion on that? You don't think they will?
They'll ask the PDEs to do it. Randall will do
it. In my spare time, the time between 3 a.m. and 5 a.m. that I don't seem to have allocated yet, I don't think so. Now, Google's being pretty clear about this, that they really are relying on the community to fill in the things that they don't have to uniquely do. Yeah. There's a lot of things they're doing driving the project, but there are a lot of things like state management that the community has been building all these alternatives, and they're waiting to see sort of who shakes it out by themselves, by having the community select that, because it doesn't need to be something that's an edict from on top of which one of these should you use, even though it should be RiverPod, but which one of these should you use, because they don't need to be in that position. They don't not that they don't care, but really the community can come up with better sources. I mean, Provider was Remy's personal project. And then the Google said, this is nice. We'll help you out to make it even better. And so that's how Provider got kind of a leap up in the documentation and the code labs and a few other places. But Google at this point doesn't really prefer Provider. It seems that way, but that's not actually how it is.
Okay.
I think also the Dart and Flutter community is just phenomenal. I mean, I've never seen such a heavy. I mean, and this is, I think, the team starts from the team that put it together and is promoting it and building it. It's so actually open and supportive of each other. I mean, it's amazing. And so it's one of the reasons it's sort of taken off so fast, and eclipsing everything else that's out there. It's really unique.
Yeah, and both Dart and Flutter were groundbreaking in a lot of ways. Dart and its ability to target everything from, microprocessors up to JavaScript, and just and being a really good language design. The kind of smart people that worked on the early Dart. If you ever want to bore yourself to tears to get to sleep some night, go read the Dart specification. It is so intricate, so word by word, carefully chosen. And it was written by some extremely smart people, thinking about a lot of different things. But that's the reason we can do sound null safety now, things like that, because that was sort of thought ahead of time as it was being created in order to give that kind of capabilities. I mean, there's some Greek letters in there. That proves how good it is. It's got Greek letters in there, But yeah, I would definitely say that the people, and then Flutter, there's amazing collaboration within Google to have come up with a way to do sort of like a streamlined Chrome, which is what one of the original goals was, in such a way that you could have, fast, responsive website on the phone sort of thing. That was sort of the original target. And then when they decided, well, we can't get Chrome to go fast enough, even if we strip everything important out of it. This is the Chrome authors, by the way, that sort of drove Flutter inside, which is why I still copyright the Chrome authors in a lot of the earlier commits, because it was the Chrome team that came up with this. And that's why there's 17 ways to make a button blue. I can never figure out the right one. Why didn't that change it to blue? Wait, which theme of default theme of this text? I don't understand. Anyway, that still gets me. I still haven't come out of that hole yet. And 2.2 changed everything, or 2.0 changed everything. So I was like, I got to learn more things about themes.